The Sustainable Transport Research at Queen's University is a twofold project. It aims to make the manufacture of metals used to build aircraft and buses more sustainable and develop new environmentally friendly materials that may eventually replace these metals. Professor Mark Price from the School of Mechanical and Aerospace Engineering explains the process.
So the big thing is we're looking at two aspects. One is how we improve, how we make the metal structures and making them lighter, but still do their job safely and last the distance. But we're also looking at new materials, and that's putting other things into metals to make them using nanomaterials. We put little additives in to make them stronger and more durable. But also there's other materials called carbon fiber composites, and it's like fabric, but it's stiffened up to make a very strong structure. And that material is very light and very strong, but because it's newer, we have to try and find out as much as we can about how it performs over a long time, how much damage can it take, and all of that contributes to a better product in the end, but also to a more efficient and clean factory. So the factories make money, the people then using it make money because there's less fuel used and so on, and the whole of the UK industrial base and economy benefits. So there's big gains to be made by doing this and by doing it well and correctly.
Key academic project member Adrian Murphy takes us through the rigorous testing procedures at Queen's.
To prove that these materials are strong enough and going to be durable enough for the life of an aircraft or a bus, we need to test them. And we need to test them from something you would see in a lab in small scale, right up to something that represents what it will see on an aircraft. So a typical specimen like this, represents a part of a wing or a fuselage structure, where you have an external smooth surface on the other side, you can't see, but on the inside you have these structural elements. And we will put that into a machine like this, which can apply combined loading to represent what a bus panel or what an aircraft panel will see in service. And we can run it through very high loads to make sure it's strong enough. We can run it through lots of small loads to replicate the life of the vehicle and make sure that the materials we've developed in the lab are going to scale so that they're valid and useful for the whole life of the product.
The potential to have an impact on the environment is really huge with this kind of work. And if you think of it this way, for every kilogram of weight that you save, say on the wing structure or the fuselage, it means that you don't need as powerful an engine, you don't need as much material to build the structure, so everything becomes that bit lighter. So the consequence then for all of us is that by being able to make the material lighter, we get these other knock-on savings everywhere. That little kilogram that you save in weight seems very small, but over 25 years is huge.